In this video, we're going to talk about sum and difference identities for sine and cosine. So first, let's talk about our formulas. So when we're talking about the sine, and we'll talk about the sum first, we are going to do sine of A cosine of B plus cosine of A sine of B. Now, if we were doing the minus, the formula is very similar, except for that there's just going to be a minus in between those two quantities. Similar for cosine, if we talk about the addition first, then we're going to have cosine A, cosine B, and it's actually a minus sine A, sine B. And so then when we're talking about the difference formula, it's actually going to be addition. So kind of keep that in mind. You will get these formulas. You don't need to memorize them, but we need to know how to utilize them. So we're going to utilize them to help us find values such as the sine of 105, as seen here in number 1. So I want to think about two angles on the unit circle that are going to add to 105. So I think of 45 plus 60. So now I can use my sum formula from above, and I can say, okay, what's the sine of 45 times the cosine of 60 plus the cosine of 45 times the sine of 60. And then I can use my unit circle values. So sine of 45 degrees is root 2 over 2. Cosine at 60 degrees is 1/2. Cosine at 45 degrees is root 2 over 2. Sine at 60 degrees is root 3 over 2. So now when we multiply fractions, remember we multiply straight across. So we end up with root 2 over 4 plus square root 6 over 4, which has a common denominator. So I'm going to have square root 2 plus square root 6 all over 4. Similarly, we can do this for radians. So I want to think about how I can break this into two things that will add to 5 pi over 12. So if I think about like pi over 12 plus 4 pi over 12, well, 4 pi over 12 is pi over 3, but this is not a unit circle value, so that's not going to help me. So if I break it into 2 pi over 12 plus 3 pi over 12, well, that's pi over 6 plus pi over 4, which are both unit circle values. So I can break this into pi over 6 plus pi over 4. So using my cosine sum formula, I'm going to have the cosine of pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. So the cosine at pi over 6 is root 3 over 2. The cosine at pi over 4 is root 2 over 2. The sine at pi over 6 is 1/2. And the sine at pi over 4 is root 2 over 2. So again, we're going to multiply straight across. So I'm going to get root 6 over 4 minus root 2 over 4. So I'm going to have root 6 minus root 2 all over 4. So we can also use these to go the other way. So if you look at number 3, I have an expanded version of one of my equations above. So if I have cosine, cosine, sine, sine, this is a cosine formula, and it's actually going to be cosine of A plus B. So I'm going to end up with cosine of 70 degrees plus 20 degrees, which is the cosine of 90 degrees, which is 0. Similarly, in number 4, I have sine, cosine of A and B. So this is the sine sum formula. So I'm going to have 5 theta plus 2 theta would be sine of 7 theta. Now I can't find the value of 7 theta because I don't know what theta is, but this is a more simplified version to write this. All right, in 5 and 6, we're going to verify these identities. So when I see cosine of theta plus pi, I'm using my cosine sum formula. So I'm going to have cosine A cosine B minus sine A sine B. This is A and this is B. So cosine theta, cosine at pi is -1. Sine theta, sine at pi is 0. So this is going to give me with negative cosine minus 0, which would be just negative cosine, which is what I wanted to get. Similarly, in number 6, I'm going to use my sine difference formula. So I'm going to have sine x cosine y minus cosine x sine y all over cosine x cosine y. Now when I have a fraction where I have two things in the numerator and one thing in the denominator, I can split my numerator so each of them get the denominator. So I took each part of my numerator and each gave it the denominator, the whole denominator. Now I can see that I have cosine y that will simplify here and cosine x that will simplify here. And I'm left with sine over cosine, which is tangent, and sine over cosine, which is tangent, which is my goal to get to in the end. All right, on the back, we're going to build some triangles and then find cosine of alpha plus beta. So sine of alpha is 4 over 5, and cosine of alpha is less than 0. So sine is positive in quadrants 1 and quadrants 2, cosine is negative in quadrants 2 and quadrants 3. So that tells me my triangle is going to be in quadrant 2. And my sine, going to think about SOHCAHTOA, so SOHCAHTOA. Sine is opposite over hypotenuse, so it's going to be 4 over 5. This is a 3, 4, 5 triangle. It's a special triangle, so we put 3 on this side, but I am in quadrant 2, so it's going to be a negative 3. So this is my alpha triangle. Now I'm going to do the same thing, but for my beta. They say sine is negative 2 over root 5. So sine is negative, which happens in quadrants 3 and quadrants 4. Tangent's positive, which happens in quadrant 1 and quadrant 3. So that tells me my triangle is in quadrant 3. Again, sine is opposite over hypotenuse, so I'm going to have negative 2 over root 5. This one I'm going to have to do a little Pythagorean theorem to figure out what my x side would be. So I'm going to have x squared plus 4 equals 5, x squared equals 1. So x is going to equal plus or minus 1. Since I'm in quadrant 3, x is going to equal negative 1. All right, this is my beta triangle. So now I'm going to do cosine of alpha plus beta. So I'm going to use my sum formula. So I have cosine alpha, cosine beta, minus sine alpha, sine beta. So cosine of alpha, so again, cosine is adjacent over hypotenuse, so I'm going to have negative 3 over 5. Cosine of beta would be negative 1 over root 5. Sine of alpha would be 4 over 5. Sine of beta would be negative 2 over root 5. So again, we're going to multiply each of these quantities straight across. So I'm going to end up with positive 3 over 5 root 5 minus negative 8 over 5 root 5. So I'm going to end up with 11 over 5 root 5. And you can rationalize it if you want, or we can leave it like this. All right, they're going to give us another scenario. So now I have alpha and I have cosine is positive, so that happens in 2. Nope, it happens in 1 and 4. Sine is positive, which happens in 1 and 2. So that tells me this is going to be in quadrant 1, 3, and 5. So then this is a 3, 4, 5 triangle, so I'll put a 4 on the y side. For my beta triangle, they tell me cosine's negative, which happens in 2 and 3, and that tangent, is also negative, which happens in 2 and 4. So that tells me my triangle is in quadrant 2. Cosine is adjacent over hypotenuse, and this is a 5, 12, 13 triangle. So I'll leave my y side 5. This is my beta triangle. So now we're going to find sine of alpha minus beta. So that's sine alpha cosine beta minus cosine alpha sine beta. So sine of alpha is 4 over 5. Cosine of beta is negative 12 over 13. Cosine alpha is 3 over 5. Sine of beta is 5 over 13. Again, we're going to multiply straight across. So I'm going to have negative 48 over 65 minus 15 over 65. So that's negative 63 over 65 would be my final answer.